think that it is reasonable to ask the following question. What is the average velocity, for instance, between time 0 and time 4? Average velocity. We define average velocity as the position at time 4 seconds minus the position at time 0 divided by 4. That is our definition. At 0 it is at plus 6. At 4 it is at plus 6. So the upstairs is 0. So the average velocity during this 4-second trip is 0. You may not like that. It may go against your intuition. Of course, I couldn't agree more with you, but that's the way we define velocity. Speed is defined differently. Speed is the magnitude of the velocity vector. And the speed, therefore, always has a positive value. And I will show you now what is the average speed between time 0 and 4. That is the distance that it has traveled in these 4 seconds. Well, let's first go through the first second. It goes from plus c6 to plus 3. So it already travels 3 meters. Then in the second it goes from plus 3 to minus 3. So it travels another 6 meters. And then in the third second, it's lazy, it doesn't do anything. So the distance traveled is 0. And then in the last 1 second, it gets very active and it travels 9 meters. Notice you only see plus signs here. There are no minus signs. It would make no sense. And this occurs in 4 seconds. So that is 4.5 meters per second. So the average speed is 4.5 meters per second, but the average velocity is 0. We could now make a plot of the velocity as a function of time. Let me put here the 4.5 so that I just have enough room here to make the velocity plot as a function of time. I'll make a new one. This is my time axis. And this is the velocity. This is 0. 1 second, 2 seconds, 3 seconds, 4 seconds. And this velocity is in meters per second. I go up here to plus 10, and here is minus 5, here is minus 6. So what do I do now? I know that the velocity during the first second is minus 6t. So it's linear. And so during the first second, this is the velocity as a function of time. It starts at 0, you can see that. And when it is here, it has a velocity of minus 6 meters per second. During the second, it remains minus 6 meters per second. So during the second, the velocity is not changing, stays there. During the third second, the velocity jumps all of a sudden to 0. You see how non-physical that is. And so all of a sudden, during the third second, it becomes 0. So there has to be somehow a connection, of course, between the two to make this physical. So in a very small amount of time, that will have to occur. That's why you get a huge acceleration here at that point. Of course, you also get an acceleration here at this point because there's also a change in velocity. And then during the fourth second, the velocity is plus 9 meters per second. And so we jump up. Let's make this plus 9. And so we have here, during the last second, and again, this is non-physical, so there has to be somehow a transition. And so here you see the velocity as a function of time. Now comes an interesting question. Is it possible, if I gave you this, so this is a given, you can't see that, Could you convert this back to that? And the answer is yes, provided that I tell you what the position is at t0, at t equals 0, x equals plus 6, and that is sufficient for you to use this information and to reconstruct that. It's an interesting thing to do, and if you feel like it, I would say give it a shot.